A Fourier transform is literally plucking out a wave and rotating it by 90 degrees in a horizontal plane. That is what the e raised to j term means. The e raised to j term means that the rotation is happening in a horizontal plane. If instead of e raised to j, it was e raised to I, it would mean that the rotation is probably happening in a vertical plane. E raised to j usually is what denotes rotation in a horizontal plane. After rotation, these frequency components, that is the different frequency components present within a wave, are arranged in the order, in the ascending order, that is, of their increasing frequencies. Every wave that you see might be a cocktail of different frequency components. Sunlight, for example, is a cocktail of different visible frequencies like violet, indigo, blue, yellow, orange, red, and invisible frequencies, invisible to the eyes, that is, like ultraviolet and infrared. All these frequency components will now be put on a graph in the ascending order of their frequencies. So red will come first on the graph and violet will be the last. In fact, even before red, there is a frequency called as infrared. It is lower than red. And even after violet, higher than the frequency of violet light, there is ultraviolet rays. So actually ultraviolet would be the last. But what is the reason that mathematicians and physicists convert the side view of a wave, that is the time domain of a wave, into the frequency domain? What do they benefit from it? What is the purpose of doing this? You might have wondered while studying Fourier transforms. The full video to this, the answer to this, is available at Patreon for just $1 per month. At $2 per month, you can actually choose the next topic that you want visualized on this channel. What if there's an ebook where at least the building blocks of math can be visualized with the help of intuitive images like the way you're seeing on the screen? What if sine theta can be visualized as a measure of how perpendicular two forces or influences are? In other words, sine theta comes into math whenever two forces are such that they produce maximum impact when acting perpendicular to each other. What if you can visualize the actual reason of why sine theta equals to opposite side upon hypotenuse with the help of an animated example as you are seeing on a screen? Now, just as sine was a measure of how much perpendicular two forces are, what if you are told that cos is a measure of how much parallel two forces or influences are? Ever wondered why cos 0 is always maximum? The more aligned, the more parallel two forces are, the greater the value of cos theta. Cos, in fact, comes into math when two forces or influences are such that they produce maximum impact when acting parallel to each other. What if complex numbers can be visualized with the help of animations like you are seeing on the screen? I raised to 1, a rotation by 90 degrees. I raised to 2, a rotation by 180 degrees. I raised to 3, a rotation by 270 degrees. And I raised to 4, a full 360 degree rotation. What if someone tells you that complex numbers comes into math when one influence splits into two or more branches either due to rotation or some other reason. One branch is called as the real part, the other as the imaginary part. What if an ebook tells you that complex conjugates are nothing but vertically opposite mirror images of each other? 3 plus 4i is like climbing the uphill of a slope and 3 minus 4i like going downhill. What if the formula of logarithms can be visualized as the log of every effect gives you the cause of that effect on the other end? The base of log is nothing but the rate at which the cause and effect relationship is changing. What if in integration or calculus dx and dy means keep adding along the x and the y axis respectively? dr would mean keep adding along increasing radius, dh along increasing height, d theta along a vertically curved path, and d psi means keep adding along a horizontally curved path. What if integration and differentiation can be seen as evil twins of each other, that is, reverse processes of each other? Integration, a process of addition; differentiation, a process of subtraction or taking away. Divergence can be visualized as the rate of change of the field as you move away from the source of the field in a three-dimensional setup. Curl, on the other hand, can be seen as the ability of a field to try to rotate you or spin you in a certain direction. I, j, and k being the three different planes of rotation, three different dimensions in which rotation can take place. What if you are told that the diagonal of a matrix is the axis around which things rotate, and that the transpose of a matrix is the entire matrix or the object that it represents rotated by 180 degree about the diagonal as an axis, and that the transpose of a matrix will be the entire matrix rotated by 360 degrees. Visualizing math 1 is the result of years of hard work done into the research of the meaning behind these equations. What these equations mean are explained with the help of simple and down-to-earth examples, animations, and analogies, so that everyone can understand. Everyone is a beginner at some point, and visualizing math is dedicated to beginners or even advanced users who wish to visualize things in order to understand. It has very little definitions and more of examples and analogies. The link to the ebook is given in the description. It is also available on Amazon as a paperback, the link to which is once again given in the description.